Hello everybody and welcome to this video where we're going to look at how we can fill in something like this that talks all about subatomic particles. So first of all, we have an example here set up for you to see what is the expected answer for every category. So let's jump right into the second row in this table. So first, we have an element that has 15 protons and 16 neutrons. Now, definitely you're going to need your periodic tables in order to solve this table. So whatever you are filling here is going to be the symbol that has 15 protons. And that's going to be, if you look at the periodic table, it's going to be phosphorus. Now, the question is, we need to fill in the symbol as shown over here, where it is the hyphen notation. So remember, there are two types of notation. You have the nuclear notation, and you have the hyphen notation as shown here. So what is the hyphen notation? So remember, the hyphen notation is written in the form of your element, dash, and then the mass number. So here we need the mass number. We don't know it yet. We're going to get it in a moment. Given that there is no assumed charge, so given that this element is neutral, then we're going to say that the number of electrons is also 15 based on the number of protons. So that is a done deal. Now, atomic number is also based on the number of protons. These two, in fact, are the same, so it's also going to be 15. Next is the mass number, and this is the important part. The mass number, by definition, is the number of protons plus the number of neutrons. So 15 plus 16, that's going to be 31. After that, we want the nuclear charge. So think about it. The nuclear charge is, from the name, the charge of the nucleus in the atom. So you don't care about the charge of the total atom, right? You only care about what's inside the nucleus. And the total charge inside the nucleus is given only by the number of protons as well, because what's inside the nucleus are either protons or neutrons. And given that neutrons are neutral, we do not include it in the nuclear charge. So we only focus on the number of protons. So that's going to be positive 15. Next, we have the nuclear symbol. So in fact, before we jump to the nuclear symbol, let's look at the symbol, the main symbol again, with the hyphen notation. So we need the mass number over here, and we just got the mass number, so we're going to plug it over here, so that's 31. Next, the nuclear symbol is going to be phosphorus, P. On the top, as you can see here, is the mass number, and then the bottom is the atomic number. So the mass number is 31, and the atomic number is 15. So we're going to write 15 down here. And that's it for the second row. And we're going to continue to fill in the rest of this table because we have different cases. We have different given now. So instead of having the protons and neutrons like we had before, we have the symbol and we have the neutrons. So we're going to work around this third row in a different way. So carbon 14, automatically given that you have the symbol for your element, it's carbon, looking at the periodic table, you can see that the atomic number of carbon is 6. And this helps us directly fill in the atomic number over here as also 6. Given that our atom is neutral, there's no charge, your number of electrons is also going to be based on your number of protons, so it's also going to be 6. The mass number is again the protons plus neutrons, so we're going to say it's 14 because 6 plus 8 is 14. Next, the nuclear charge. The nuclear charge is based only on the protons, so we're going to say it's positive 6. And the nuclear symbol is going to be carbon, 14 on the top because this is the mass number, and down here is the atomic number, which happens to be 6. Next, we have the nuclear symbol now, and this helps us a lot because given that we have the nuclear symbol, it allows us to know a lot of things. In fact, probably everything directly. This is the mass number, it is 16, so you directly plug in 16 here. This is the atomic number, which is 8, so the atomic number is 8, which means the number of protons is also 8. The number of neutrons you're given the formula up here. The number of neutrons is equal to A minus Z, which is basically the the mass number, which is 16, minus the atomic number, which is 8. So you're going to get 8. So the number of neutrons here is simply 8. So I'm just going to keep that over here. Finally, the nuclear charge. Again, the nuclear charge is always based on the number of protons, so that's going to be plus 8. And finally, the symbol is O-16. Next, we're going to look at argon 40. Argon 40, given that you have your element, you look at the periodic table, and it's a noble gas. It's in group 18. It has 18 protons. Its electrons are also 18, given that this element is neutral, and the atomic number is also 18, given that it's based on the protons. Next, the mass number is 18 plus 22, which means that the mass number is 22 plus 18, which is 40. The nuclear charge, and in fact, we didn't even have to add these together. Just a fun fact, we did not have to add these together to find the mass number. In fact, we could have just gotten it from here. That would have been even easier. The nuclear charge is, again, the number of protons. So here it's positive 18. And finally, the nuclear notation, it is argon. Up here is the mass number, which is 40. And down here is the atomic number, which is 18. And that's for argon. Now, finally, we have this element here. We have the mass number and we have the atomic number. And this is how powerful these two numbers are. They're going to allow us to know every other thing about the atom. So just by having the mass number, just by having the atomic number, you are able to find everything else, just like all the cases before. So the atomic number is 20, which means you go to your periodic table, you search for which element has an atomic number as 20, and that is going to be calcium. So calcium dash, and this is your mass number ready for you to use. So you're going to say calcium 40. Next, the number of protons is also 20 because the number of protons are the atomic number. And number of neutrons is, again, I remind you, it is A minus Z, which means it is 40 minus 20, which means it is 20 as well. So the number of neutrons are 20. Now you might have a question, do you have to show your work in these cells? Well, it depends on the question on the exam, of course. If the question is a short answer question, then yes, you're expected to show your work. But if it's a table format, then I don't really need to see your work unless I explicitly tell you. But usually in a table format, I do not ask for you to show your work. Number of electrons, given that this is a neutral atom, then the number of electrons will be based on the number of protons, and that's going to be 20. And the nuclear charge is also based on the number of protons, so it's going to be positive 20. And finally, the nuclear symbol, we know that it's calcium, we know that the mass number is 40, and we know that the atomic number is 20. So this is our nuclear notation. And that's it. This is how we are able to fill in this table.